Hello, ladies and gentlemen. Today we're going to be talking about changing attributes. So you should have your changing attributes notes in front of you, and you should also have a calculator and a pencil. You'll need all three of those things, notes, calculator, and pencil, as we work through these notes. So, changing attributes. You may be thinking to yourself, what is an attribute? You'll notice at the top of your notes that we have a little bit of a close or a sentence frame here about what an attribute is. An attribute is a characteristic or a property of an object. So when we're thinking about attributes with regards to rectangular prisms, we're thinking specifically about the length, width, or height of our rectangular prism. So we're going to take this rectangular prism, and using these formulas and our different dimensions, our different characteristics, our different attributes or properties, we're going to look at the height, width, and length of this rectangular prism. So the height for this rectangular prism is 4. The width for this rectangular prism is 2. And the length is 3. Now you'll notice on your notes that the volume and the surface area of what we're going to call our original figure, if you want to write over here the word original, that might be awesome. So you should write down this word original here. And then in order to look at this rectangular prism, first we're going to figure out the volume and the surface area of our original figure. So the volume formula, that we used can either be found on your formula sheet right here underneath the rectangular prism, or you can find it here on your notes. So let's write in the volume formula, which is V equals LWH, length, width, height. And then we also have our surface area formula, which is surface area equals 2 length width plus 2LH plus 2WH. And we can rearrange those because of the commutative property of addition. So if we wanted to write 2LH plus 2LW plus 2WH, that would be okay. But this is typically how you're going to see it written and how you'll find it on your formula sheet, which you should have gotten as well. Sorry about that. So, moving on, we're first going to look to see what happens when we change an attribute. And we're going to look specifically at what happens when we double our length. So you'll notice on the figure that we've already doubled the length for you. And our height will stay the same at 4, our width is 2, and our length is now 6. So if you want to pause this video and find the volume and the surface area on your own. Alright, so you should have found the volume and surface area on your own. Now, here we're going to fill in what the volume and surface area would have been when we doubled the length, and what the surface area was, the volume and surface area, was when we doubled our length. And then we want to think about what happened when the length was doubled. So when we doubled the length, our volume became 48 inches cubed. And when we look at our volume, we can see that it went from 24 to 48. Well, 2 times 24 is 48. So our volume doubled. Now let's look at our surface area. Our surface area, on the other hand, went up to 88 inches. Well, it did increase, but it's kind of tricky to figure out what exactly it increased by. So we're just going to say that our surface area increased by 36. So go ahead and write that information down. Now let's move on to the next one. And we're going to go back to our original. And now we're going to look at what happens when just our width changes. So you'll notice that our length has gone back to 3 inches, but now our width is 4 inches. So our height is still the same, it's 4 inches. Our width is now 4 inches, and our length has gone back to the original 3 inches. So take a minute, pause this video, use your calculator and your pencil to figure out the volume and the surface area. Alright, now that you're back, you should have gotten the volume to be 48 inches cubed, and you should have gotten the surface area to be 80 inches cubed. Alright, so when we doubled that width, we just fill in this information from right here, we fill it in down here. So when we doubled the width, our volume became 48 inches. Well, how did we get from 24 to 48? Well, once again, we multiply it by 2 so the volume doubled. Now the surface area. Let's think about what happened to the surface area. If we take this information over here, plug it into our table, we now have 52 and 80 inches. Okay, well that increased, but it only increased by 28. So now let's try one last thing. Let's see what happens when we divide the height by 2. So we've gone back to our original figure for the width. We've gone back to our original figure for the length. And now our height is 2 inches. So we fill in those values. Because half of 4 is 2. That's how I got 2 inches here. So pause this video again and find the volume and find the surface area. Now that you're back, you should have found the volume was 12 inches cubed. And you should have found the surface area was 32 inches cubed. Well, let's see. So our original was 24 inches, and taking this value and putting it into our table, we got that when we halve the height, we got 12 inches cubed. Well, what is the relationship between 24 and 12? Oh, right, just like we were working with our common ratio recently, we know that if we divide by 2 is the same as multiplying by half. So the volume was halved or was multiplied by 1/2. Divided by 2 or multiplied by 1/2. Okay, so now if we look at our surface area originally was 52 inches and now it's at 32 inches. Well, 32 inches means that our surface area is decreased, and it's decreased by 20 inches squared. So write those things down. If you need to pause and go back at any point or ask your teachers questions, make sure that you're doing that. All right, so let's think about this. Let's look at, now when we look at all of our tables here, we can see all this information is now in one place, so we can look at them all together. Up here, when we doubled our length, well, when the length doubled, our volume doubled. When we doubled our width, our volume doubled. When we halved our height, our volume was halved. So if you'll notice here, whatever we do to the length, the width, or to the height, the volume changes in the same exact way. It changes, we're going to call that the scale factor. So it changes by the same scale factor. So for example, if we were to triple our length, we would triple instead of this saying volume doubled, it would say volume tripled. But for now, we've got volume doubled, and then volume halved. Let's look at our surface area. Our surface area here, when we doubled our length, our surface area increased. When we doubled our width, the surface area increased, but by a different amount. And then when we halved our height, it decreased, but not by anything the same of our increases. So we can see that the surface area changes in the same way, in the sense that when we're doubling something, it's getting larger. So here, our surface area is also getting larger. It's increasing, but not by a specific amount. And same down here, when we're decreasing by something because we're getting smaller, but not by a specific amount. All right, we're almost done here, ladies and gentlemen. Let's look here at our final conclusions. So in conclusion, I talked about a scale factor. A scale factor is the number you multiply or divide the attribute by. Remember, our attributes are our length, width, and our height. So go ahead and write that down. The number you multiply/divide the attribute by. When you increase one attribute, the volume increases or multiplies by the same scale factor. If you remember on our last slide, when we multiplied something by 2, our volume and surface area, or our volume, just multiplied by 2. And the surface area, if you'll remember, it increased, but it didn't increase by a certain amount. Now when we decrease the attributes, the volume decreases or multiplies by the same scale factor. It multiplies by a fraction. So, once again, just like our common ratio in sequences, we're not actually dividing, but instead we're multiplying by a fraction. And it will always be a fraction if it's getting smaller. And then last but not least, our surface area decreases. So that's all about changing attributes. Go ahead, if you need to pause and copy all this down, do so. I hope that you've learned a thing or two, and make sure that you're asking your teacher questions or re-watching this video if you're lost. Have a good one.